Happy Tuesday, Kings and Queens. It is Tuesday, October 27th, 2020, and we are jumping into Math 7, Unit 1, Lesson 9b. Our classroom norms for today are that your camera should be on at this point, your mics are muted unless you are speaking and sharing with the class, and that you guys are ready to learn. Our materials for today are that you are using your Math 7 Spiral notebook to copy down notes. We are working on page 20, and you will also need a pencil and your student companion for today's lesson that can be found in Google Classroom. So we are going to talk about probability and sampling for today. We are day 2 of what are probabilities. Once again, you will need your notebook for some notes and your student companion so you can get credit for today's live session. So our standards for today are 7.sp.5, 7sp6, 7sp7, and 7sp.7a. Our objectives are that students will generalize the relationship between the probability of an event and the number of possible outcomes in the sample space for an experiment in which each outcome in the sample space is equally likely. We are also going to list the sample space of a simple chance experiment and use a sample space to determine the probability of an event and express it as a fraction, decimal, or percentage. Our mathematical practices for today are MP3 and MP6, which are to construct viable arguments and critique the reasoning of others and attend to precision. As always, we want to make sure that we're ready to take notes and work collaboratively. We will pause the video here so that you guys can copy down your standard and your objectives. All right, let's move right to our engagement activity, which is entitled, Which Game Would You Choose? So, which game would you choose to play and explain your reasoning? I want you guys to determine, would you choose game 1, which says you flip a coin and win if it lands showing on heads, or would you want to choose game 2, where it says you roll a standard number cube and win if it lands showing a number that's divisible by 3. So I want you guys to take about 1 minute, think to yourself, and tell me, which game would you choose, game 1 or game 2? And then I would like for 3 of you guys to share what your answer would be and why. If it were me, I would rather play game 1, since half of the coin would land so that I will win. That means that I have a 50% chance. In game 2, there are only 2 out of 6 ways to win, if I land on a 3 or if I land on a 6. So I only have 2 out of 6 chances, whereas the first game I have a 50% chance. So with that being said, let's move to today's goals. So our goals for today are that we want to be able to use the sample space to calculate the probability of an event when all outcomes are equally likely. We also want to be able to write out the sample space for a simple chance experiment. So these are my goals for today. So let's look at our exploration activity. Our exploration activity can be found in your student companion, and it is going to be called What's Possible. And in order to prepare for this exploration activity, there's some things that we need to discuss so that you are fully prepared. So let's talk about what it means to be random. And we want to make sure that we're copying this down in our journals as a definition. So in mathematics, when we talk about random and more specifically probability, it means doing something so that the outcomes are based on chance. So, for instance, like spinning a spinner, not when you're just guessing on a test, but random means doing something that the outcomes are based on chance. So let's make sure that we have this definition for random in our notes. Once again, random just means doing something so that the outcomes are based on chance. We also need to remember that each possible result for a chance experiment is called an outcome. So remember, outcomes are just the possible results. So each possible result for a chance experiment is called an outcome. Let's make sure this is in our notes as well. And I'll read it one more time. Remember, each possible result for a chance experiment is called an outcome. Now we're going to move to our next portion that we need to have into our notes, and that is going to be a sample space. And a sample space is the set, that means it's going to be more than one, of all of the possible outcomes. For instance, if I look at this spinner, all of the outcomes are the numbers 1 through 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be the sample space. If I'm looking at the number cube here, there are 6 outcomes. So the set of outcomes will be 1, 2, 3, 4, 5, 6, and that is going to be your sample space. So once again, we're copying down this definition into our notes. Your sample space is the set of all possible outcomes. Now, looking at your student companion, we'll have a chance to work on this together using our definitions. So it says work for 10 minutes with your partner or group, and then we'll talk as a class. However, I would rather us just do this as a class. So we're going to take about 4 minutes of independent work time, and then as a class, we're just going to share out what our answers are for this portion. So we will pause the video here briefly for you guys to work on the exploration section where it says what's possible. And it says for each situation, list a sample space. Remember the sample space we just talked about, and it's in your notes, and tell how many outcomes there are. Okay, and then if you look below that, it says, next, compare the likelihood of these outcomes and be prepared to explain your reasoning. And then you're going to answer the last question about the spinner. So we'll take about 4 minutes because this shouldn't take you too long. And I want you to label what you think the sample space is, the outcomes, and then answer the 2 questions below. So we'll pause here. And then after those 4 minutes are up, you guys will share with your classmates. All right, at this point, we're going to pause for 2 minutes for anybody that would like to share out their answers for the exploration activity, and then we'll come back together as a whole group. All right, so let's discuss what our answers were. So for number 1, the sample space for letter choice A, where it says Han rolls a standard number cube, the sample space is 1, 2, 3, 4, 5, and 6, because those are the actual choices that could happen. So the sample space is if you list out the numbers 1, 2, 3, 4, 5, and 6. The number of outcomes are that there are 6 of them. So the sample space is you can get any number 1, 2, 3, 4, 5, 6, and there are 6 outcomes. For B, where it says Claire spins the spinner once, the sample space would be red, blue, green, or yellow. And there, the number of outcomes are 4. So the actual options is what you're listing out for the sample space, and you get red, blue, green, or yellow, and there are 4 outcomes. For C, where it says Kieran selects a letter at random from the word math, the sample space would be M, A, T, and H. That one might have been a little tricky, but M, A, T, H. And there are 4 outcomes because there are 4 letters in the word math, letters M, A, T, and H. For letter choice D, it says My selects a letter at random from the alphabet. So, what are our options here? There are a lot. It would be A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Yes, that was a lot to type in, but all of those were your sample space options. And how many outcomes are there? 26. So, hopefully, you remember your alphabet from kindergarten because that was important. And last but not least, letter choice E. Noah picks a card at random from a stack that has cards numbered 5 through 20. The sampled space would be starting at 5. So numbers 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. and there are a total of 16 outcomes. So those were your answers for the first section. If we need to go back to any, we will definitely do so. If not, let's move to number 2, where it says, next, complete the likelihood of these outcomes and be prepared to explain your reasoning. So, is Claire more likely to have the spinner stop on the red or blue section? Both are equally likely, is what you should have for letter choice A. Both are equally likely because they're equal sections. Next, it says, is Karen or Mai more likely to get the letter T? Well, Karen is more likely to get a T since there are fewer possibilities in the sample space. Remember, Karen only has 4 options, M, A, T, or H, whereas Mai has to choose from the whole alphabet. So Karen is more likely to get a T since there are fewer possibilities. And the last part, it says, is Han or Noah more likely to get a number that is greater than 5? And the answer is going to be that Noah is more likely to get a number that is greater than 5 because even though he has more possibilities in the sample space, all but one of them are greater than 5. Okay, so that was the answer for the second section. And for number 3, about the spinner, it is more likely to spin the current day since there are only 7 possible days but 12 possible months. So let me read that one more time for you guys so that you understand. It says it is more likely to spin the current day since there are only 7 possible days, but there are 12 possible months. So let's keep moving. So, in this activity, all of the outcomes are equally likely within each sample space. Sometimes it is important to have an actual numerical value rather than a sense of likelihood. So, to answer how probable something is to happen, we assign a probability. And I want us to spend some time on this slide. So, please make sure that you're copying this down into your notes. So, once again, to answer how probable something is to happen, we assign a probability. And probabilities are values that are between 0 and 1. And that means it can be expressed as a fraction, a decimal, or a percentage. So, an example would be something that has 50% chance of happening, like a coin landing heads up. That means that the probability is 1/2 or 0.5 because that's how we express 50% as a fraction and a decimal. So for probabilities, they're values that fall between 0 and 1 and can be expressed as a fraction, a decimal, or a percentage. We'll pause here to make sure that you get this entire slide into your notes. Okay, now let's move to the next part. It says to answer how probable something is to happen, once again, we can assign a probability. And we know that when each outcome in the sample space is equally likely, we may calculate the probability of desired event by dividing the number of outcomes that the event occurs by the total number of outcomes in the sample space. So, for instance, if we have all equal parts, like 4 options out of 4 options, but we want to know what is the likelihood for something, we can put the desired outcome, so what we want to happen, and divide it by the total outcome. So if I have a bag of 4 toys and I want to know what the probability is of getting 2 toys that are red, out of the 4 toys, you would take 2 and divide that by 4. So it will be the desired outcomes divided by the total outcome. So let's copy this into our notes. We'll pause here. Okay, so let's just discuss a little bit more. So let's say that we have a standard number cube that is rolled, and we want to know what is the probability of rolling a 3 and explain. Well, let's first talk about the options that we have. If we have a number cube, the options are 1, 2, 3, 4, 5, and 6. So that means that how many outcomes are in this sample space. So the sample space is 1, 2, 3, 4, 5, and 6 because these are all of my options. So that means that we have a total of 6 outcomes. And we want to know once again, what is the probability of rolling a 3? So 3 is only one of the 6 options. So the probability would be 1 over 6 because there is a 3 and 6 outcomes in the sample space. So because 3 is only one of those options, the probability, remember we just said in the last slide, would be the desired outcome. So there's only one desired outcome divided by the total, which is 6. The total is 6 outcomes. So your probability is 1 over 6. So let's just recap what our goals were for today. We wanted to be able to use the sample space to calculate the probability of an event when all outcomes are equally likely. And we also wanted to write out the sample space for a simple chance experiment. So just to recap a little bit, remember, if we chose a letter at random from the English alphabet, how many outcomes are in the sample space? Remember, there would be 26 outcomes in the sample space. If you choose one letter from the English alphabet, how many outcomes are in the event that a vowel, not included Y, is chosen? Well, our vowels are A, E, I, O, U. So that means that there are 5 outcomes. If we talk about what is the sample space of a chance experiment, remember the sample space is the list of possible outcomes for an experiment. And when there are more outcomes in the sample space, the probability of a single outcome occurring is lower. So that's what happens a little bit. And then we also want to know when there are 100 different outcomes in the sample space that are equally likely, what is the probability that a specific outcome will happen? Once again, we just said that when there are more outcomes in the sample space, the probability of a single outcome occurring is lower. So, our word wall for today, we did talk about a lot of different things. We talked about probability, we talked about what random means, and what sample space means. And we do have these into our notes. So, of course, we want to make sure that we keep these definitions close to us because they are important. Now we're going to move to our evaluation activity. We're going to take about 5 minutes of student work time for you to complete the letter of the day activity, and we're going to complete this in your student companion. So please take this time on your own independently to read the description of the evaluation and to answer those 3 short questions, and then we'll come back together. So we'll pause the video at this time. All right. Thank you guys so much for doing the evaluation activity. At this point, please go ahead and submit that into Google Classroom. Once again, submit the student companion into Google Classroom in order for you to get credit for today's live session. Now, let's move to our closure. We spent some time going over our recap, and let's talk about our independent activities. So today is Tuesday. So you have a short Mobius math assignment. All of the directions are posted in Google Classroom. Of course, if you can get into Mobius math, then the problems will be posted as an attachment. And last but not least, your Wednesday asynchronous assignment is going to be out of your Big Ideas workbook. And again, all of the directions will be in Google Classroom. Guys, have a wonderful rest of your day and enjoy your Wednesday. And we will be back together on Thursday for another live lesson. Have a great one.